Hello everyone. Today we shall discuss the stratigraphy of the Central Indian Tectonic Zone. The Central Indian Tectonic Zone is a very important part of the Precambrian stratigraphic horizons of India. The Central Indian Tectonic Zone, which, as the name suggests, lies in the Central Indian portion, it is basically a mobile belt and the this region Central Indian tectonic zone lies where we call the Satpura mobile belt. The Central Indian tectonic zone, or more commonly referred to as CITZ, it has two very important perennial rivers which flow westward, and this CITZ, it has Mesoproterozoic age. Time and again, you must have heard of some earthquakes in the central Indian region. So, this portion is still tectonically active. Several earthquakes of high to low intensities keep on occurring in this zone. And this zone is a hot cake for research by the structural geologists, and it's a very important region. We will discuss it in detail. So let us begin. So this map of the central and peninsular India I have given over here to mark the position of the central Indian tectonic zone. If you remember the previous classes, you would easily understand that the location of the CITZ is coincides with the portion from where the Satpura mobile belt runs. This location which I have shown over here, this is Amarkantak. I have deliberately given this location because, first of all, this is the place where I work at the IGNTU in Amarkantak. But of course, that is secondary. The most important thing is that this location is the origin of three important rivers: Narmada, Son, and Johila. The Narmada River, as we all know, it runs westward. So Amarkantak has, let us forget about Johila, it's a small river, but two very important rivers, Narmada and Son. The Narmada River originates from Amarkantak and flows westward to drain into the Arabian Sea near Bharuch in Gujarat. While the Son River, it traverses northward, enters UP, and then meets the Ganga River in Bihar to drain in the Bay of Bengal. So, this is a very interesting fact that the Narmada River, it drains into the Arabian Sea, while the Son River, it becomes a tributary of the river Ganga, and it drains into the Bay of Bengal. The Narmada River, it flows in a straight path, a straight course. Okay, so the Narmada River has a straight course. Another important river that flows through this region and has a straight course is the Tapti River. Yeah, the second river is the Tapti River. So the straight course of Narmada and Tapti rivers, it implies that they both are flowing through a fault plane. Fault plane. Now, if we talk about the Central Indian Tectonic Zone, the Narmada and Tapti rivers, they mark the north and southern boundaries of the CITZ respectively. Roughly, if we talk about it, CZ. Some other important rivers which flow in this region, then this river over here that goes and meets somewhere here, this river, it is the Mahanadi. Then another river which drains into the Bay of Bengal, this river over here, it is the Damodar River. Damodar River. And as I had mentioned, this place is Amarkantak. Now, the straight course of the Narmada and Tapti River implies that they are flowing through a fault plane. The Narmada and Tapti rivers, they roughly mark the northern and southern boundaries of the CITZ. And this zone through which Narmada and Son rivers they flow, it is also called as Sona, Son Narmada lineament. So if we consider this as the Sona, Son Narmada lineament, and if this is the Tapti lineament, the region lying in between these two rivers is the Central Indian Tectonic Zone. The Central Indian Tectonic Zone is important because it gives us the information about the coming together of the Bundelkhand and Deccan protocontinents. So, CITZ, it gives information about the coalescing or coming together, coming together of Bundelkhand and Deccan protocontinents. Continents. If we try to draw it over here, so this portion over here, it is the Bundelkhand protocontinent. This is the Deccan protocontinent. Deccan protocontinent exists only till here. Okay. This portion, which is the Palghat Kaveri shear zone, is much younger. The age of CITZ is Mesoproterozoic, while the Palghat Kaveri shear zone, it is Neoproterozoic. It is younger. It is younger than CITZ. But interestingly, the Palghat Kaveri shear zone, it has become tectonically inactive, while CITZ is still active. So you can understand how important this region is. So if we try to draw a schematic diagram, so this was the Bundelkhand protocontinent, and this portion over here, it was the Deccan protocontinent. And the joining together of these two uh, portions of the land masses, the information is given by the Central Indian Tectonic Zone. That is why this region is very, very important. The Central Indian Tectonic Zone, it has the deposits ranging from Paleozoic to Cenozoic, but yes, of course, it is not a continuous deposit. It has the Paleozoic deposits represented by the Permian rocks. Mesozoic deposits are represented by the Cretaceous formations, and Cenozoic is represented by Paleocene and Eocene. So there are lignite deposits of Paleocene and Eocene. Apart from it, we also have the portions of the Deccan volcanic province, which belongs to Upper Cretaceous or Late Cretaceous. All these evidences, they are suggestive of freshwater to transgressive marine settings. So if we try to draw in the Central Indian Tectonic Zone its formations, if this is the western coast of India, and then these are the two rivers which make the north and southern boundaries. So here there are, so this is the Narmada Son lineament, and this is the Tapti lineament. Then there are some deposits which belong to Paleocene Eocene lignites. So this is the Paleocene Eocene lignite deposits. Then there is in the central portion there is the Deccan volcanic province, which is Upper Cretaceous in age. Then close to the areas like Jabalpur and all, some evidences of lower Cretaceous dinosaur egg nests have been found. Dinosaur egg nest. This is the lower Cretaceous. Lower Cretaceous. Then in this region also, there are some Gondwana coal fields as well. So the SECL, Southeastern Coalfields, Sohagpur region, then Shahdol region, all these areas, they have the Chhindwara, they have the Gondwana coal fields, which are Permian in age. On the easternmost fringes, again, there is the Damodar Valley coalfields and all. That's why I had shown you the rivers. So this is again the Gondwana coalfields and all. So we can see here that roughly the central Indian tectonic portion, it has sediments or it has rock formations which are Paleozoic. These are represented by the Gondwana, Permian coal deposits of Gondwana. Then the Mesozoic has the lower Cretaceous deposits represented by the dinosaur fossils and egg nest, and it has the upper Cretaceous in form of Deccan volcanic rocks, Deccan volcanic province. The Cenozoic is represented by the Paleocene Eocene deposits, the lignites. So this is the uh, range of the rocks of geological time found roughly in the central Indian tectonic zone. So all these formations, they vary in their environment of deposition and they suggest freshwater to transgressive settings. So we have freshwater rocks as well as we have the marine rocks exposed in this. So if we go to the details of the central Indian tectonic zone, now the northern and southern margins, to be more specific now, the Son Narmada North Fault, that is SNNF. It marks the northern margin of CITZ, while the central Indian shear zone CISZ, it marks the southern margin of CITZ. And in between these two, we have several geological formations. So let us try to draw a rough map first and then we'll go into the details of it. So starting from north, so this is the north over here. Start from the north. So the northernmost geological formation over here or geological entity is the Bundelkhand Craton. Bundelkhand Craton. Then there is the Vindhyan Basin or the Vindhyan Supergroup of rocks. The Vindhyan Supergroup is bound on the west by the Deccan Volcanic Province. the DVP. The southern portion of the Vindhyan Supergroup, it is marked by the Son Narmada North Fault. The Son Narmada North Fault, also marks the northern boundary of the Mahakoshal Supergroup. Mahakoshal Supergroup. The southern boundary of the Mahakoshal Supergroup is marked by Son Narmada South Fault. Okay, so we have Son Narmada North Fault and Son Narmada South Fault. The Son Narmada South Fault, it separates the Gondwana sediments and some isolated patches of the Deccan volcanic province from the Mahakoshal Supergroup. So all these are the this is all Deccan volcanic province. All these are the Gondwana sediments over here. Is Gondwana. All these are Gondwanas over here. Then south of it is exposed the saucer supracrustal deposits. Saucer supracrustal, and then comes the Central Indian Shear Zone. And of course, in this region, a lot of crystalline rocks are also preserved and exposed. Crystallines. The CISZ, it separates the overlying saucer supracrustal from the Bastar Craton. Then some crystalline rocks are also exposed over here. So what do we see over here is that the Central Indian Tectonic Zone, it basically lies between these two cratons, the Bundelkhand Craton and the Bastar Craton. And it is also uh, flanking the Vindhyan Supergroup in the north and the Bastar Craton in the south. The Central Indian Tectonic Zone starts with the Son Narmada North Fault and it ends with the Central Indian Shear Zone. And in between these two lineaments or these two fault planes, we have the Mahakoshal Supergroup, the Gondwana sediments, the Deccan Volcanic Province, saucer supracrustal deposits, and several crystalline rocks. To be more specific with the map, if we try to draw it, then we start always with the Bundelkhand Craton. So this is the north. The Bundelkhand Craton. South of Bundelkhand Craton lies the Vindhyan Supergroup. So let me draw it with a different color. the Proterozoic Vindhyan rock sediments, shallow marine sediments, we all are aware of this. So this is the Vindhyan Supergroup. The Vindhyan Supergroup, as I have already told you, the southern portion of the Vindhyan Supergroup is marked by the Son Narmada North Fault. Son Narmada North Fault. SNNF. The Son Narmada North Fault marks the northern boundary of the Mahakoshal supergroups. The Mahakoshal supergroup, which has age of almost 1.7 billion years. The Mahakoshal supergroup, it its southern margin is marked by the Son Narmada South Fault. Son Narmada South Fault. Now starts the uh, typical case of the Central Indian Tectonic Zone, where the Deccan Volcanic Province is exposed. Then there is Gondwana Sediments. So these are the Gondwana sediments over here. Let me write it. Now, in between these two, some granulite belts are also exposed. First of all is the macrohar granulite. This is macrohar granulite belt. The macrohar granulite belt is flanked by the Balrampur fault in the south. So this is the Balrampur fault. South of the Balrampur fault lies the Bethul Belt. It's very famous for the lead and zinc deposits over here. So this is the Bethul Belt. Bethul lead and zinc belt. To the south of the Bethul Belt lies another fault plane which is known as the Tan Shear Zone. Tan Shear. To the south of the Tan Shear lies another granulite belt which is named as Ram-Kona Katangi granulite belt. This is the Ramakona Katangi granulite belt. Okay. To the south of the Ramakona Katangi granulite belt lies the important manganese deposits of Saucer group. So this is the Saucer supracrystals or saucer belt with manganese deposits. A lot of crystallines, as I had told you previously, are present in this zone as well. This area has a lot of these gneisses over here which are exposed. These are the gneisses. To the south of the saucer belt lies the Bhandara Balaghat granulite belt. So this is the Bhandara Balaghat granulite belt. To the south of the Bandara Balaghat granulite belt lies the Central Indian Shear Zone. This Central Indian Shear Zone. Two granitic batholiths are exposed to the south of the CISZ. They are the Malanjkhand granite, Malanjkhand granite, and we have the Dongargarh granite. Dongargarh granite. So these are this is the more or less geological map of the Central Indian Tectonic Zone region, and in this the CITZ starts from the south of the Mahakoshal supergroup and ends with the or we can include this portion as well. So this is the CITZ. This is how it looks like. So the Son Narmada North Fault is the northern margin of the CITZ as well as the Mahakoshal supergroup. Central Indian Shear Zone, it marks the southern margin of the CITZ. Son Narmada South Fault marks the southern margin of the Mahakoshal supergroup. Apart from these, we have rocks like granulites, gneisses, schist belts, Deccan volcanics, Gondwana rocks. Okay, so we can see here that the rocks present in this zone, they are indicative of uh, intense tectonic activities. If we try to draw a cross section along the north-south strike of CITZ, then what it would look like. So if we start from the north, so what we are going to draw is the cross section along north-south strike of CITZ. So once we draw it, you all should try to draw it in this manner, and this question, if it is asked in your competitive examinations, if you draw it like this, you're going to get good marks. So let us start with the northern side. First of all, in the northern portion, there is the Bundelkhand Craton. Bundelkhand Craton. To the south of the Bundelkhand Craton lies the Vindhyan sediments, Vindhyan sedimentaries basically. So these are the Vindhyans. Vindhyans. To the south of Vindhyans, to the south of Vindhyans lies the Son Narmada North Fault. And then there is another fault which is called as Son Narmada South Fault. Between these two fault zones lies the Mahakoshal sedimentaries. So we have the Mahakoshal rocks. Mahakoshal. South of the Mahakoshal lies the Macrohar granulite belt. The Macrohar granulite belt is separated from the Bethul Belt by the Balrampur shear zone. So there is another shear zone over here. This is the Balrampur shear zone or Balrampur fault, and then this is the Macrohar granulite. To the south of the Macrohar granulite belt lies the lead zinc Bethul belt. Let us draw it by a different color. Okay. The lead zinc Bethul belt is again separated from the Ramkona Katangi granulite belt by the Tan shear zone. So there is another shear zone over here. This is the Tan shear zone, and this is the Bethul belt, lead and zinc. South of the Bethul belt lies the Ramkona Katangi granulite belt. So this is the Ramakona granulite. Ramkona granulite has the manganese saucer belt to the south. So this is the Mn saucer belt. And thereafter comes the central Indian shear zone. It separates the Malanjkhand granite from the saucer belt. So this is the Malanjkhand. And then there is the Dongargarh granite. So this is the south. So from north to south, the CITZ and it looks like this. And in this, the CITZ is from here to here. Now, if we go ahead further, the portion south of the Son Narmada South Fault till the central Indian shear zone, it is basically an accretionary prism. So, from the Son Narmada South Fault, which includes now the macroher granulites till the manganese saucer belt, from here to here, this is basically an accretionary prism, which means that the portion which is represented by the central Indian shear zone, it is there is a subduction zone over here. Also, we can see here that the granulites, the Macrohar granulite, Rampuna Katangi granulite, and these low grade rocks, they are occurring together, which means that the granulites which were formed at much deeper levels, they came up or they got exhumed by faulting or thrusting. Okay. So this subduction zone implies that there must have been some oceanic plate that got subducted. This basically was the Satpura Ocean, which got closed by the subduction of the oceanic plate, and which the lithosphere which consisted of the Satpura Ocean and the Bastar Craton, which got subducted beneath the Bundelkhand Craton. So if we try to draw a line diagram, then it would look somewhat like this. This was the Bundelkhand Craton, and beneath this, this was, quite possibly the Satpura Ocean, and this portion over here, it was the Bastar Craton, and the convergent plate motion led to the subduction and closing of the Satpura Ocean. So this is the Bundelkhand, and then so this portion over here, it is the subduction zone, and the Bastar Craton collided, subducted over here, Bastar. This closing of the Satpura Ocean led to the formation of the crumpling and formation of the accretionary prisms, which consisted of the saucer deposits, the granulites, Bethul, then again granulites. So this accretionary prism basically, it exists from Central Indian shear zone, then it has the manganese saucer deposits, then granulites, then again granulites it has, and then the Son Narmada South Fault. So this portion over here, it formed the Satpura Hills. Satpura Hills. So this would look somewhat like this. Let me show you in the next diagram. So this is the Bundelkhand Craton. Then the Vindhyans. Then this fault is the Son Narmada North Fault. This is the Son Narmada South Fault. And of course, this is the Mahakoshal deposit. Now, these are those hills. This is the Macrohar granulite. This is the Ramkona Katangi granulite. Between these two granulites lies the Bethul Belt. And then beyond the second granulite, that is the Ramkona Katangi, there is the Saucer manganese deposits. This portion over here, it is the central Indian shear zone, and here lies the subduction zone. So close to this lies the Malanjkhand granite. And this is the Bastar Craton. This is the subduction zone. Now, these granulites which appear on the surface over here, they must have formed somewhere over here at the deeper levels. These granulites were formed at these levels, then they got exhumed. During subduction, what happens is that the downgoing slab, it melts, leading to magmatism, and these form the island arc granites. So the Malanjkhand and the Dongargarh granites, they both are the island arc granites. The magmatism also gives the age of subduction. The age of Malanjkhand granite is 2.5 billion years. So we can safely assume that this subduction, it took place at 2.5 billion years. Now, this subduction zone, it is located at the central Indian shear zone. So what did we understand from over here is that the Satpura Ocean got closed by the subduction of the oceanic plate beneath the continental plate over here, and this subduction beneath the Bundelkhand Craton, it brought together Bundelkhand and Bastar Craton, and the oceanic sediments, they got crumpled and then they got raised in form of these accretionary prisms. So this portion from here till here, it is the accretionary prism. So here you will get the Deccan hills, Gondwana hills, all these are present over here. Hills. So I hope you understood this, how the formation of accretionary prism took place over here. So the Central Indian Tectonic Zone is a major suture zone which joined the Bundelkhand and Deccan blocks at 2500 million year or 2.5 billion year. So in the very beginning, I told you that these two proto-continents, they were brought together and they were joined together by the Central Indian Tectonic Zone. So we can now understand this, that at 2.5 billion years or 2500 million years, so if this is the, you know, Indian subcontinent, so this is Central Indian Tectonic Zone. This is the Bundelkhand proto-continent, and this is the Deccan proto-continent. So they were brought together at 2.5 billion years, by the uh, Central Indian Tectonic Zone. And then this Palghat Kaveri Shear Zone, it brought the peninsular tip of the Indian subcontinent during Neoproterozoic. Neoproterozoic. Thus, we understand that at 2.5 billion years, Bundelkhand was a separate continent, Deccan was a separate continent. They joined together by the closing of the Satpura Ocean, while the Palghat Kaveri Shear Zone, it brought the southern tip of India in the Neo-Proterozoic. Okay, now if we try to bring this in tabular form, then the north-south tabular cross-section of CITZ shall start with the Vindhyan and Bijawar basins and Gneissic slivers, the Bundelkhand Craton, then comes the Son Narmada North Fault, Mahakoshal Group, Son Narmada South Fault, Macrohar Granulite Belt, Balrampur Fault, Bethul Group, Tan Shear Zone, Rampuna Katangi Granulite Belt, Saucer Group, Balaghat Bandara Granulite Belt, and the Central Indian Shear Zone. South of which are the Sakoli and Chilpi belts and gneisses and the Bastar Craton, and of course the Malanjkhand the granite and the Dongargarh granite. So this portion marks the stratigraphic horizons of the Central Indian Tectonic Zone. The Son Narmada North Fault, it extends all along the outer periphery of the Vindhyan Basin. Outer periphery of Vindhyan Basin. It was active until Neoproterozoic, and it marks the northern boundary of both the Mahakoshal belt as well as the CITZ. So you may get such a question in the prelims examination of GSI or any other competitive examination where they may ask about the northern boundary of CITZ coincides with the northern boundary of which supergroup. It is answer will be the Mahakoshal. The Mahakoshal supergroup or the Mahakoshal supracrustal belt, it is east northeast, west southwest trending. The northern and southern boundaries of Mahakoshal Supergroup are marked by Son Narmada North Fault and Son Narmada South Fault, respectively. These both faults they together constitute the Sona fault system. So these two they constitute the Sona fault system. The Son Narmada North Fault separates the Mahakoshal belt from Vindhyan Basin in the north and Siddhi Nices. So Siddhi Nices they are regarded as equivalent of Bundelkhand granite. So Narmada South Fault it separates Mahakoshal belt from the Proterozoic granites and gneisses of Central Indian Tectonic Zone. It is covered for most part by the Deccan Trap, Gondwana sediments and Quaternary alluvium as I had shown in the previous maps. The main rock types of Mahakoshal they are quartzites, carbonate, chert, banded iron formations, Greyvac, argillite, and mafic volcanics. The Mahakoshal belt is intruded by granites on either side of the belt along the Son Narmada North and South faults. Very famous examples are the Madan Mahal granite, then Jhirka Dandi granite, then we have the examples of Rihand Renu Sagar granites, etc. Age of the Mahakoshal has been given as 1.7 billion years or 1700 million years. The south of Mahakoshal lies the Son Narmada South Fault. It's nearly east-west trending and probably formed in Paleoproterozoic and has shown the evidences of repeated reactivation. South of the Son Narmada South Fault lies the Macrohar granulite belt. These are granitic rocks which contain enclaves of amphibolite to granulite facies. So the Macrohar granulite belt it consists of amphibolite to granulite rocks. The enclaves they consist of sillimanite quartzite, corundum sillimanite quartz schist, garnet cordierite sillimanite, biotite granulite, amphibolite, and retrograded mafic granulites, banded iron formation, and calc silicates. Age has been given as 1.7 to 1.8 billion years. South of the Macrohar granulite belt lies the Balrampur fault. Balrampur fault is also commonly referred to as Shahdo lineament. Another MCQ, if may ask. The Shahdo lineament or the Balrampur fault, it passes through Gondwana sediments, Bethul Belt margin, and gneisses. And it is marked by brecciated zones, dolerite dikes, shearing, hot springs, etc. The Bethul supracrustal belt, it is situated between the Mahakoshal and Saucer supracrustals. It is overlain by the Gondwana sediment and Deccan Trap on three sides. And there is a narrow corridor which is connected to gneissic terrain in the north of the Saucer belt. Son Narmada South Fault separates the Mahakoshal belt and the gneisses of the Central Tectonic Zone. And there is a major ductile zone also called as the Tan Shear Zone. So it is a ductile zone which occurs between the Bethul Belt and the Saucer Belt. The Bethul Belt, it consists essentially of gneisses and granites and several supracrustal rocks. Also, Bethul is rich in lead zinc mineralization. Age has been given as 1.5 to 0.8 billion years. Next comes the Shear Zone. The Shear Zone, which is a ductile zone, it has thickness varying from 1 to 7 kilometers. These are plutons of granite which have developed myelonitic foliation, and they belong to granodiorite alkali granite suit. Age has been given as 1.14 billion years approximately. The Ramkona Katangi granulite belt, it consists of granulite lenses and enclaves which occur within the megmatitic gneisses and granites. These basically are retrograded pyroxene granulites and garnet cordierite granulites. They give an evidence of peak metamorphism of 850 degrees Celsius and 8 kilobar pressure, followed by decompression at 800 degrees Celsius and 4 kilobar pressure, and a cooling phase at 650 degrees Celsius and 4 kilobar pressure. So the peak metamorphism 850 degrees Celsius, 8 kilobar pressure, decompression at 800 degrees Celsius and 4 kilobar pressure, and the cooling phase at 650 degrees Celsius and 4 kilobar pressure. Next comes the saucer supracrustal belt. It is an arcuate fold belt. It is surrounded by Tirodi gneisses and is separated from Bethul Belt in the north by the Shear Zone and from Bastar Craton in the south by the Central Indian Tectonic Zone. The Saucer Belt has richest manganese deposits and it is dominated by QPC soot with little or no volcanic, so quartzite, pellitic, and carbonate rocks. It shows Barrovian regional metamorphism, kyanite, sillimanite type of the green schist facies in the south to amphibolite facies in the north. South of the Saucer supracrustal belt lies the Balaghat Bhandara granulite belt and the central Indian shear zone. The CISZ truncates the uh, dominant north-south structural trends of the Kotri, Dongalgarh, Sakoli, Sonakhan belts of Bastar Craton. This is marked by intense myelonitization. Intense myelonitization. The lithology, it consists of granitic gneisses and other supracrustal lithologies. It has narrow lenses of basic granulites. This whole region, basic granulites, magnesium aluminum pelites, aluminum rich pelites, banded iron formation, garnet sillimanite quartzites, etc. The age of the Balaghat Bhandara granulite belt is given as 2.67 billion years, while the age of subduction at CISZ is given as 2.5 billion years. 2.2 billion years. And then to the south of it lies the Sakoli and Chilpi belts and gneisses and the Bastar Craton. So this completes the stratigraphy of the Central Indian Tectonic Zone. And to read this, you can take the help of the books of Geology of India by Ramakrishnan, Vaidyanathan, and of course, uh, to understand it more better, the tectonic and the geological map portion, you should also watch the videos of TK Biswal sir. I have used his videos, and then some portions of it I haven't covered in this lecture. But if you want to go into much detail, you should use those books and then refer to his lecture. Then the book by K.S. Waldia, the geodynamics of India, that's a very good book, and it gives lot detail about the Central Indian tectonic zone. So I hope this helps you in preparing for the questions on the CITZ. Thanks a lot.